All right, howdy folks, welcome back. So last time we learned that R could do some basic things like create messages using, or character strings, if you will, using the double quotes, do basic arithmetic, so add, subtract, multiply, divide, and then do exponentiation. We didn't cover logarithms, but it does logarithms and some other stuff as well. We learned about how R uses logic to make comparisons, and there's some logical comparison operators. So greater than, less than, greater than or equal to, less than or equal to, equal to. So this is, I didn't mention this last time, but it is worth mentioning. The two equal sign next to each other is actually how we do a comparison of equals to. And then not equal to is this bang operator, and the bang equal to or not equal to. And we mentioned that code comments are very, very important. We talked about that everything is in R is an object. Everything in R is an object. And that's an important statement that we will unpack over the course of the semester. But for now, just remember it. And objects are basically like a basket or container that holds things. So we use this syntax to create an object called X that contains the number 2. And so this showed up in our environment pane over here on the right. So we've got an object called X that contains that holds the value of 2. And this is kind of like a container of food in the fridge that's got a label on the outside that says your name on it or says what it is. And then inside there's the contents of the container. And this is where we kind of left off, and we're going to pick back up here with, there's exercises here. This should have done at the end of the last lesson. I didn't call it out, so I apologize. Take a minute and work on these exercises right here. So I'll pause the video and you go work on these exercises. Okay, so hopefully you've had a few minutes to work on these exercises. Let's move on to talking about vectors. Okay, so up to this point, we've seen most of these things. If you see here, this is a single value false, a single value false, a single value true, the single value 15, the single phrase howdy folks, the single value 2, single value 8, single value 6. Okay. Now, if you've learned a little bit of some mathematics called linear algebra, then you may know to interpret these things anytime you see a single value as something called a scalar. Now, a scalar is basically a number the way that we've traditionally worked with numbers our entire life. 2 plus 4 equals 6. So that is a single value 2 added to a single value 4 equals a single value 6. But if you think about it, in terms of public health, we rarely ever have a single value floating anywhere. We often have an entire vector of the heights for our participants, or the weights for our participants, or if we're doing research on HIV, then we've got the CD4 counts for all of our participants, or perhaps we've got the systolic blood pressure for all of our participants, or if we're looking at health disparities related to cancer, we've got the 5-year survival rates for all of our participants, broken up by African American versus white, all of these other things. It's rarely ever that we have a single number like 15. I mean, it doesn't come up very often. There are a few times where we will have a single number, and often they're p-values or something related to that. But even then, you usually comes like a pair of numbers. You've got a confidence interval, lower and upper limits. But in terms of the data that we work with, we rarely ever have just single values floating out into the ether. Most of the time, we're dealing with a vector of values. Now, vectors in R are not what we expect when we go back and think about vectors in mathematics, where a vector is like, okay, if I've got the vector 2, 5, that means I go 2 in the x direction and 5 in the y direction, and I end up with this line that connects them, and that line with the arrow at the end is the vector. That's an idea of a math. That's like the mathematical idea of a vector. But in R and in a lot of computing environments, a vector really just means an ordered set of information. Okay. So here we're going to use another function. This is a function right here, which we haven't covered yet. But the colon operator, what we can do is if we type 0:9, it's going to create a vector of all of the integers from 0 to 9. So 0, 1, 2, 3, 4, 5, 6, 7, 8, 9. All right. This is not a single number. This is an ordered set of numbers. This is a vector. And in R, it doesn't necessarily have to be a vector of numbers to be a vector. It doesn't have to be an ordered set of numbers to be a vector. It can be an ordered set of basically anything, and it can be a vector. And we'll get into more about that in the lesson 6 and lesson 7, where we talk about atomic vectors versus non-atomic vectors. But for now, understand that R works with vectors just as quickly as it works with scalars. In our head, if we say, okay, well, what's 2 times 2? We can do 2 times 2 is 4. But here, R will interpret this 0, 9, this entire vector times 2. And well, what did I do? Let's have a learning moment. I didn't type the 2 yet. Forgot. I got ahead of myself. And so R changes the prompt from this like a greater than symbol to a plus sign, saying, I'm still waiting for you to finish this expression. So this is a bit of a review from last video, courtesy of me typing faster than my brain is willing to go. So we're saying 0 to 9 times 2. And what it does, R does not first say, okay, well, give me, I need a minute. I need to do 2 times 0. Well, that's 0. And then 2 times 1, well, that's 2. And then 2 times 2, well, that's 4. Like, it doesn't take the time like a human would need to do. A human would need to take the time and actually perform each one of these operations and then kind of give you back the answer. R technically does that, but it does it so fast that you don't even notice. Okay, R is designed from the ground up to work with vectors. And I think it was a few videos ago, we'd asked the question like, well, why R? Why not some of these other languages? And this isn't a benefit that's exclusive to R, but R has 2 adjectives that are usually used to describe it. One is a vectorized language. That means it's designed to work with vectors or sets of data. And 2, R is a functional language. And we'll cover that more in detail later in the semester, but basically that means that you can build out more R code yourself once you learn the rules. So whatever method that you need to get done in R, you can do it. This is unlike SAS or Stata, or in lesser extent lesser extent SAS, but because SAS you can use proc IML to start writing your own methods, but SAS or Stata or some of these other point and like Jump, for instance, where you have to point and click, or even Microsoft Excel, where you have to rely on the methods being added in, you get to write the methods yourself. And so R is extendable in that way. And the word that we use is, we say that R is a functional language. That means that you can create your own functions to do analysis. But circling back, R is a vectorized language. That means that it is designed, so let me do this again so it all fits on one line, easier to see, 0 to 9 times 2. R is designed to work with data in vectors and apply the same exact operation element-wise across the entire vector, and it does it that fast. Okay, so here are just some examples. I recommend that you go through and type these, and then I want you to work on these exercises. So we're going to take a couple. Of minutes. I'm going to pause the video here. Go back and work on these exercises. Okay, so you've taken a couple of minutes. You've worked through the exercises, and you're kind of understanding how R works with vectors a little bit better. R does some things called recycling. R for vectors, the order matters a lot. So things to learn about this. Now, I mentioned earlier that R is a vectorized and a functional language. Well, that means that we need to talk about, well, what in the world is a function? Okay. So a function is something that you want to do in R. Now, technically speaking, we've seen functions already. We've seen the less than symbol. We've seen the double equals symbol. We've seen the multiplication symbol. Even this thing right here, this quote symbol, that's its own function. Now, they don't look like functions in the traditional sense, like this colon operator doesn't look like a function in the traditional sense. Most of the time, functions have parentheses to say, hey, this is a function here. So when I mentioned earlier that we could create an ordered set of just about anything, not just numbers, we can create an ordered set of words. So this is an ordered set of character strings. This is also a vector, all right? And we used the C function for concatenate. Concatenate is basically a fancy word that says smash things together. And it's going to create a character vector. So this isn't like a vector where I gave the example before of a vector 2, 5, where you go 2 in the x direction and 5 in the y direction. This is a vector of characters, a vector of letters, a vector of symbols. Well, symbols in terms of like the English language, not necessarily symbols in R, which we will cover that distinction later in the semester. But this is a vector of a whole bunch of letters and words, and we can put basically anything we want inside of these character strings. So this is a vector. This whole thing is a vector. This, the letter C, is the function that we can use to create new vectors. So it's a very important function. It's the concatenate function. Functions almost, let's see, is this true all the time? I think almost all the time the function is going to have a couple of components. These components. Number one, the function is going to have a name. If it doesn't have a name, it's going to have a symbol. Like, for instance, right here, the multiplication sign, it's not named multiply. It's not like you can't read it and you read the word multiply. It's just a symbol. But that is its name. The symbol is the name of this function is the multiplication symbol. It has arguments. In this case, the arguments look kind of strange. One argument goes ahead of it, the other one comes behind it. This function has names, or this function, this concatenate function, this is the name of the function is just the letter C, and it has arguments. The arguments is basically everything that goes inside of the parentheses, and then be like, this is a vector. So that all of the stuff that goes inside are the arguments to the function. And then here's what's important. This function does something, okay? This function creates a vector. But how does it do it? Well, we don't know, but we know that somewhere there is some computer code that is attached to the name C, so that whenever I supply the arguments, this is a vector, it's going to put them all together. So the function, the last function component is what the function does, all right? Now, there's a little bit, we're going to get into a little bit more specificity here in terms of the arguments. So first of all, let's look at the mean function. The mean this is like just the arithmetic average. So add up all the numbers and then divide by how many you have. The argument has a name. So the name of the argument is X. And the values that we're going to be supplying is the sequence of integers from 1 to 6. And then somewhere baked inside of R is what the function is actually doing, where you would get to add up 1 plus 2 plus 3 plus 4 plus 5 plus 6, and then divide by however many numbers there are, okay? So this is, I promised you that R can do logarithms, so here's an example. we can, so this is kind of the components of the function. We've got the name of the function, the name of the argument, the value of the argument, and then what we can't see, what's hidden behind the computer code, is the actual commands to find the arithmetic mean of the numbers 1 to 6. And then this is another piece of, this is important right here. We can sort of like chain functions together. So if I wanted to create a vector of 10, 100, 1,000, these are the multiples of, so 10 to the first, 10 to the second, 10 to the third, and then find their logarithm, I can just put one function call inside of another function call as long as I have the right parentheses in the right place. And you can imagine that we can nest calls inside of other calls, and this can get unwieldy. We're going to learn a little bit more. I'm not sure if it's more sophisticated, but we're going to learn a technique a little bit later in the semester for how to chain function calls there to make it easier to read. But for now, I'll just put them inside of each other. So this is where you take a minute and work on some exercises again. So I'm going to pause the video. I hope you had some time to work on these exercises. I hope you learned something. But again, I want to recap that functions here. This is they have some components. Number one, they've got a name. So the name of the mean function is mean. Many times the arguments themselves have names, but not all the time. So for instance, this function, the C function, isn't necessarily required. I'm not required to supply names to the arguments. And then the arguments have values. So in this case, the value is going to be 1 to 6. Up here in this example, the values are going to be Professor, Gabriel, Jay, Odom, PhD, THD. And then under the hood, so behind the curtain of what you don't see, there's going to be some computer code that actually goes and finds this average of the numbers 1 to 6, or creates this character vector of all of this information. And here's where we're going to stop the video. When we pick back up next time, we're going to talk about how can we get help. All right. So see you soon.